Okay, so we're back and we're on page 2 of day 4 notes, and we have to talk about distance. And distance between any 2 points is the absolute value of the difference of the coordinates. So you could do some subtraction, and you just have to remember that distance will always be positive. You're never going to measure a distance and have it be a 0 length or a negative length. And so we are going to go ahead and find the following. They want us to find the length of UF on this number line. So if I trace from U to F, that red line segment, they want to know how long it is. And so all we have to do is really count. And so we would say 1, 2, 3, 4, 5, 6, 7, 8. And so UF has a length of 8. Or what the definition up there says is that you can take the coordinates of -5 and 3 and you can subtract them. And if we to go ahead and subtract them, that gives us -8. Absolute value are these bars, and absolute value of a number always makes it positive. It's the distance it is from 0 on the number line. And so -8 is 8 units from 0 on the number line. And so that is where our answer of 8 comes from. The next one asks us to go ahead and find the length of Fn. So Fn is a little bit longer. In fact, it's 1, 2, 3 units longer. And so 8 plus 3, and Fn would be a length of 11. Then they also want us to find the length of NU. So if we trace from N to U, that is actually only 3 units long. And when they refer to a number like 3 for the length of a line segment, they don't put the bar over the 2 letters like we used to see or we saw on the front. Next thing we have to talk about is between. And between. A point is between 2 other points if all 3 points are on the same line. That's huge. Same line they have to be on. So right here in this diagram, B is between A and C because they're all 3 points are on the same line. And when that happens, we get this nice little equation. So it says AB, which is this line segment here, and let's say AB is 2 units long. And if we add BC, which is the other line segment on that same line segment, and let's say it's 5 units long, then what happens is we get the whole line segment, and that would be 7 units long. And so we're going to do the same thing, except they take our numbers away, and sometimes they give us expressions instead. So our job is to remember anytime we have something like this is that it's the part plus the part equals the whole. And if there were 8 parts on the line segment, then we would add 8 parts, not just 2, to equal the whole. So how many ever parts added all together always equals the whole. And so if we look here, we can see that this is just one part of the line segment. So we'll take 2x plus 7, and we will add the other part, which is 28, and that will equal the whole. And the whole always goes from the beginning to the end. And we use these cool looking brackets. You can get a little bit fancy with your brackets and use something like that if you want. But that 4x is representing the whole because it's in those brackets. We're going to go ahead and combine our like terms, and we end up with 2x plus 35 is equal to 4x. And we're going to go ahead and subtract our 2x from this side to this side. And we end up with 35 equals 2x. We're going to go ahead and divide by 2. And x comes out to equal 17 and a half. Now we have to make sure in geometry that we answer the question. So going back up, it says, if S is between R and T, find the length of RT. Well, remember, R to T is the whole thing, which is 4x. Well, we just figured out x is 17 and a half. So 14 times 17 and a half will give us a grand total for RT being 70. And then we get full credit for the question. Okay. Let's move on to the next example. Next example has no picture, so we're going to have to make sure we draw our own. That's huge in geometry, is being able to draw your own picture to represent the problem. When your eyes see the picture, it helps your brain to think of what to do. So it says if point X is between points Y and Z. And remember, guys, in order to be between, you have to be on the same line. Although these bars over these letters here indicate that these are going to be line segments. So instead of putting arrows on my ends of my line here, I'm going to put endpoints to turn it into a segment. And I'm going to go back and reread so I know where to put my letters. If point X is between points Y and Z, so I'm going to put Y here and Z here, or vice versa. You could have put Z here and Y here. And then it says point X is between, and a lot of people put it smack dab in between. That's actually a more specific point called a midpoint because it's in the middle. I don't want to put it in the middle unless it's a midpoint specifically. So I'll slide it down either closer to Y or closer to Z. It does not matter. I'm going to go ahead and put it closer to Z, and I'm going to call this X. Now I can go ahead and label my expressions on there. They said from X to Y, that's 4X minus 3. And ZY, from Z to Y, from the beginning to the end. So I'm going to use a bracket to represent the whole. That's 11X minus 60. And then X to Z is 2X plus 13. And they want you to find the length of XY. Really, they want you to find the value of X and then plug it in to find the length of XY. And so this is that same equation. Part plus part equals whole. My first part is 4X minus 3. Plus my second part is 2X plus 13. Equals my whole, which is always underneath my bracket. And then we're just going to combine like terms. 4X and 2X is 6X. Negative 3 plus 13 is positive 10. I most likely would subtract the 6X first. And I would get 10 equal to a 5X minus 60. I would then add my 60. And I end up with 70 equal to 5X. I'm going to go ahead and divide by 5. And X is going to come out to equal 14. And most people will box that up and call it a day, but you have to remember in geometry, they may and most likely will ask you to go back and plug that value of X in order to find a specific length. In this case, guys, it's XY. And so I'm going to find the expression that represents XY, and I'm going to go ahead and sub out the X and put in the 14. And 4 times 14 minus 3 is going ahead and give me 53. So we'll say XY equals 53. And that one's finished. Okay. One last one on this page, and it's a little bit tougher. And I know it's a little bit tougher because of one thing that I'm given. And that one thing that I'm given is this term right here, x squared. That tells me most likely in this question, I'm going to have 2 answers. But I'm not going to get the 2 answers unless I do a process called factoring, and I can't factor unless I'm equal to 0. So that tells me something. But first, we got to set up our page so we know how to set up our equation. So it says if point U is between points S and N, and again, there's that between word, which means that they're on the same line. And if I look at those bars over the SU and the UN and the SN, they're telling me that they're line segments. So I'm going to give this one endpoints. And go back and read so I know where to put my letters. If point U is between points S and N, so I'm going to call this S and call this N, and it doesn't say U as a midpoint, so I'm going to slide it closer to S or closer to N, it doesn't matter, and we'll call that U. Now I can go ahead and label my expressions. SU is X squared plus X, and UN is just X, and SN, the whole thing, is 12 minus 2X. And the same equation, part plus part equals the whole. And so we'll set it up as X squared plus X, which is one part, plus X, which is the second part, equals the whole, which is 12 minus 2X. And that squared term, remember, you always want to keep him positive, and he is positive right there where he is. And so we're going to leave those 3 terms there. Okay. Remember, that square term means you have to factor, which means you have to get equal to 0. And so these 2 terms over here are going to come on over individually. That 12 is positive, so we're going to go ahead and subtract it. Nobody like him, so I don't really have anybody to put him underneath. And then that 2X, he's negative, so I'm going to add him. Now, you do have options here because he's an x term and you have two x terms here, and so you can put them wherever you want. Okay. But there won't be any more terms on that side, and so that will be our equal 0, which is perfect. What do we have over here, though? So we have an x squared, and nobody like him, so he comes down. But we do have three x terms, a positive x, and a positive 2x for a grand total of positive 4x. And then that minus 12. And now you can tell he looks like a really good looking, easy trinomial. So we'll set up our x box. Our multiply is negative 12, and our add is 4. And if I think about the numbers, the only numbers that I can think of that could possibly multiply to 12 and add to 4 are 2 and 6. However, to get a 4 out of 2 and 6, my 2 is going to have to be negative, which is good because then they multiply to negative 12 and they add to positive 4. And now I know I have the correct numbers. And so we'll split up the easy trinomial into x, and one with a minus 2 and one with a plus 6, and we are equal to 0. And we're going to keep going. We take this factor of x minus 2, we set them equal to 0. We take this factor of x plus 6, and we set it equal to 0. And now we just created two little tiny mini equation, and we're just going to solve each one. In this one, we're going to add 2, and we end up with x equals 2. On this side, we're going to go ahead and subtract 6, and we end up with x equals negative 6. And in algebra, it says two answers, but in geometry, we usually only take one of them. And the reason for that is that in geometry, line segments can't have a 0 length or a negative length. So I'm going to think that the negative 6 is the one that's going to go away, but you really can't say it's going to go away until you take it and you plug it in. And the easiest expression to plug it into is this one right here. If I take that negative 6 and plug it in, I'm saying that the length of UN is negative 6. That can't be right. And so we're going to go ahead and say it doesn't make sense to the problem or the picture, and so we reject it. There is no negative length. All right, so we're going to keep x equals 2. However, again, we have to go back up and make sure that we answer the question. They want to know the length of Sn, and Sn is the whole thing again. And so we have to go to the whole expression, take out the x, and sub in our x, which is 2. This has subtraction and multiplication in it, and according to PEMDAS, P-E-M for multiplication, D-A-S, S for subtraction, multiplication comes first. And so we'll do 12 minus 4, and 12 minus 4 is 8. And we can now say Sn is equal to 8. One more thing I like to do is go back and plug it in up here too. So that means that UN has a length of 2. And if I take my 2 here, 2 squared is 4. 4 plus 2 is 6. And this works because this is a 6 and 2, and the total is 8. 6 plus 2 equals 8. Part plus part equals whole. And so it works out. And so I have a good feeling that all of this lovely math is wonderfully perfect. All right, so we have one more page of notes, and so I will see you in the next video to do those. All right.